Okay. Hello, everyone. Good afternoon, good morning, good evening, wherever you are. Thank you for joining the GeoScience and GeoEnergy webinar of 19th of November 2020 today. Sebastian, Geiger from Heriot-Watt and myself from TU Delft are both grateful to you all to supporting this initiative for good cause, to combat work from home isolation during these pandemic and to connect with each other once in a week. Please subscribe to our channel, access the past talks in the case you have missed any of them. All of them are quite interesting for all of you as geoscientists and geoengineers. We are also thankful and grateful to all our distinguished speakers who have kindly supported and accepted our invitation graciously and supported this initiative for good cause, help the geoscience community connect with each other and share their challenges, advancements, and visions during these difficult times. We aim to continue with this initiative for years to come and already have full list of speakers till March 2021. Yes, Sebastian and I were thinking perhaps when we retire, we also give a webinar ourselves too. So also to the end of the year, as Christmas time is approaching and end of the year is happening, we are gonna feature all of you, all our more than 1,500 subscribers to this channel. If you're thinking how, try to think about a 10 seconds message that you would like to send to all your friends and colleagues in geoscience community with the, I don't know, right environment you like to be there as well. And we are gonna let you know how you can send the videos to us. We are gonna collect them all together and release it here. So everybody has 10 seconds to be featured in this channel. And stay tuned about details. Especially also our keynote speakers have this invitation open as well. And there is initiative, a Tea Time Talk series run by junior researchers. For junior researchers, if you're PhD and postdocs, please do attend, volunteer to give a talk, build up your network. You need to do that quite early at your professional career. Now, to the lecture of this week. We are pleased and honored to welcome our distinguished keynote speaker of this week, Mr. Paul Zeppenfeldt from Shell. I will read a few lines about Paul and then we will have the lecture with us. Paul leads Shell's subsurface technology organization, which delivers the competitive technology edge for Shell in the areas of geophysics, geology, petrophysics, reservoir engineering, reservoir modeling, subsurface data integration, including digitalization, through a global organization of some 400 staff. The technology and digital portfolio spans both classic oil and gas exploration and development and is expanding into the CO2 sequestration, hydrogen storage, and geothermal. Focus is on strong upfront business alignment on the technology portfolio, research effort, support models, economics, and deployment targets. Paul has MSc in aerospace engineering from TU Delft, where I work today, joined Shell since '91 and stayed there since then, held prior operational reservoir engineering, development, planning, and management assignments in UK, Germany, Netherlands, Saudi Arabia, and Russia. So quite a dynamic career he has had. And from aerospace, now working as geoscientist, that's quite a curious also trajectory as well. For our students, please see, you could end up in different businesses as well after you graduate with us. Paul is with Shell since 1991. We are pleased and honored to host you, Paul, today. Thank you very much for kindly accepting our invitation. Thank you for that. To the audience, please note, like always, the lecture will last for about half an hour, followed by questions and discussions. Like always, please type in, text your questions, and as much as time allows, Sebastian will go through them and chair the discussion session. So thank you once more, Paul, for accepting this invitation. We are all looking forward to hearing your lecture today. Please.
Well, thank you very much, Hadi. Can you hear me loud and clear still?
Yes, yes, very well.
Yeah, very good. Well. Okay, hi everybody, and yeah, thank you, Hadi and Sebastian, for the opportunity to join this quite impressive, great list of speakers in the GeoScience, GeoEnergy webinars here. Is quite impressive, the quality and the kind of the technical depth that the previous speakers have been able to bring to this, and so I'm very honored to to be here, and actually hope that I can maybe add a bit to the series, contributing from a business vantage point. How do we look at all of this? And frankly, it's also a bit of a welcome change for me, because I'm heavily involved in some of the kind of the restructuring work we're doing in Shell to get us ready for the future. So this is actually a very nice a change from that, which is quite a busy period, as you can imagine. So thanks for also saving me a few minutes on my introduction. And before I really get into it, just need to put up a slide which you can't really read. This is a slide with a lot of fine print, but really what the message is that when we talk about in Shell about the climate ambition, and we made important announcements also on our aspiration to be net zero carbon footprint company by 2050. We are very aware in Shell that if you look at our plans right now, and of course we are increasingly putting capital into energy transition. If you would play out the business plan as it is today, you would not yet get to the goals of the Paris Agreement. So we're very aware that our portfolio of projects will very much evolve over time, and it's only by indeed changing what we put our capital in that we can actually get to that net zero emissions target. So this is a very much a period of change. And I find I've got exposed to this whole area really since 2018, and I find it an incredibly actually exciting and dynamic period that we're in. So maybe next slide we can indeed. I will not talk very much more about myself. Hadi did a great job on that. Just to say that when you have questions, time is short, and I'm by no means an expert on everything in deep detail, but we'll try and capture all your questions and come back to, because I think Hadi and Sebastian are capturing questions also if we don't get round to answering your specific one. So on indeed this slide, just last month we in Shell we presented kind of a new strategic direction, and really splitting up our business into three distinct parts. And one is where we're probably known for in many areas in terms of the upstream, and this change that's going to happen with the transition is something that is we're absolutely sure that is the future, and these changes will be in trends over time. So we've announced that indeed our upstream business, our oil and gas business, is absolutely essential for us in terms of our cash flow and also to fund the change of the company. So we've said that we'll probably be in future in fewer places in the upstream. And also what you'll probably see more is that in the past, all companies tended to be driven often by volumes of barrels or barrels of oil or million scf per day in gas. We're very much more going to be focused on value. And indeed, also perhaps also partially due to the COVID crisis that affects us all, the high watermark of actual oil production in the world may have already actually been reached already. And then the second part of our portfolio will be what we call transition businesses. You should be thinking about things like refining. We've also announced that our refinery business will focus a lot more. And also LNG, which I spent a lot of time in the gas part of Shell, and we think really LNG is absolutely essential as also to help with the transition, for example, to move people off coal into LNG. And then finally, we have the third part, and that is what we call the growth businesses. And you could think of, for example, a hydrogen business as one of such businesses. And I'll talk a little bit more about that in a minute. So next slide, please. And this is a little bit more specifically about our climate ambition. When you're aware of the differences between different types of emissions, your scope 1 and 2 is more the direct emissions, and scope 3 is the emissions that are caused by using our products. And of course, it's very important, if you have a climate ambition, you start first looking at yourself, so looking at your own emissions and minimize leakages, particularly of things like methane, of course. So we fully get it that increasing amount of our capital will need to go into energy transition projects. And we're really talking about billions and billions of dollars. So what we're doing right now is, of course, people are keen to see, why you're not investing 20, 30, 40 billion now. Well, what we are doing right now is laying the groundwork to be able to do that. And I'm given that I have the privilege of leading a technology organization. Technology often is then, comes at the forefront of making things possible, making things possible reliably, making things possible economically. That's the groundwork that you need to do to, in a way, to earn the right for all that capital that we're going to need. And another big piece, what we're working on, and many colleagues of mine are working that both on the CCUS front and also the hydrogen front, is to work on, what do value streams really look like? How can we turn this into a business? Because if we want to make that change, and it's going to need a massive effort, then the economic framework needs to be made for that. And then, of course, that is where we also need to work very closely together with customers. But it's not all just pie in the sky, jam tomorrow, whatever you want to call it. There are real big projects coming on, and I'll show you some of those later. And I think coming back to this is a subsurface community, probably in majority. We're very keen that we kind of take the opportunity here and not see the energy transition as, people that have worked oil and gas for a long time as a threat. I think there's just incredibly exciting additional areas of application of subsurface knowledge coming on. So, this is something we really like to grab with both hands, and don't be, like Kodak, not seeing the advent of digital cameras and trying to stick to what it was doing. We're very clear that we are going to need to develop, but I think we've got some things that we can bring to the party. So let's maybe move one slide next, and look at some of the big themes in the energy transition that we're seeing. And if you look at CCUS overall, without CCS, forget Paris. And we believe that in time we're going to need something like 12 gigaton per annum of storage. And one big project I'll show you in a minute, that was already a mega project in Canada, that's able to store 1 megaton. So it means we need 12,000 of these projects to go. So that means 12,000 times you need to invest that capital, understand the geology, talk to your stakeholders. So there's an absolute phenomenal effort that certainly Shell is not going to do on its own, but it's incredibly exciting how this will change this picture. There's about 51 CCS facilities exist. 19, well, they don't exist, but they're kind of in the portfolio. 19 are kind of operating, and the others are in various stages of construction. And if you think about CCUS, what makes it also so interesting is these are not just technical issues. Yeah, clearly you need to look at storage sites from a technical viewpoint. How much, what's the storage capacity? How can we contain the CO2 in the ground? Transport, injectivity. How can we monitor that it stays down there, and the stakeholder picture? So that is a very kind of techno-economical challenge that I've always found in my career the most interesting ones. And for our own target, so our scope 1 or 2, our own emissions, we think by 2030 CCUS is going to deliver 85% of that. So it's going to be a big chunk. Then also, of course, you can look at energy. So CCS for blue hydrogen would be the next one. Hydrogen I'll talk about in a minute, but of course we're very excited about hydrogen, but really we have to, of course, get rid of the associated emissions. So blue hydrogen is what you'll see in the medium future. Of course, the holy grail is green hydrogen, where you can really generate hydrogen with renewable energy. The next big theme, energy storage for renewables. This is where we start thinking about particularly things like hydrogen storage. If you can get that right, then you almost have the best kind of battery that you can imagine. And in geothermal, last but not least, increasingly of interest this theme. Here in Holland, we're blessed with kind of geology there that makes geothermal possible, and we've got an exciting announcement coming that I'll talk about in a minute. But you can do a lot with geothermal. Broadly, you might think about shallow geothermal more for heat networks, and heat represents about 40-50% of the energy demand in Western Europe, so that's quite a lot. If you want to go deeper, you might be able to link geothermal to electrical power. Now, moving on to next slide, please, and let's start talking about those actual projects that are actually happening. And this is a project that we are a partner in Canada, and this is a CCS project that has been operated for a while. So I'll show you two projects and note the contrast between the two. This first one is first of all onshore. It's a single site, and it deals with our own emissions. And this is emissions from a plant called the Scotford upgrader. And what that does, it gets bitumen from oil sands, and you note that we've taken the strategic decision to move away from the oil sands business, but we still have a share in this facility. And what this facility does, it adds hydrogen to this bitumen to make synthetic crude oils, and of course that comes with CO2 emissions. So here, this Quest CCS is something that's been storing already safely and effectively about 4 to 5 million tons of CO2. It does about 1 million tons per annum. So remember, we need 12,000 of these projects. And I think you see also that this has been done in great cooperation with the Canadian and Albertan government. This is something you do together because they created the framework of also having a carbon tax, which we think is incredibly important to make this possible. And clearly we get invaluable learnings from a project like this in terms of how you operate a CCS project. Now, let me move you to the next one, and then you see how things are starting to evolve. And this is a project where Northern Lights project, where the Norwegian government has just taken final investment decision. And here you start to see a difference. So no longer it's our own emissions and it's onshore and it's a single site dealing with its own emissions. Here we're now separating out the where the emissions are generated and where it is stored, because here with our partners Total and Equinor, we are now storing somebody else's CO2. Yeah, so now you start to see kind of the beginnings of kind of a network, a kind of a trade between for dealing with emissions. And these are the emissions that are coming, for example, from waste to energy plants or cement factories, and they all have kind of made contracts with the venture to store their CO2 emissions. So again, this of course benefits from the pretty advanced thinking in this whole area from the Norwegian government. So you do this again together, but you can now see already how things are evolving over time. And but yeah, this is again a multi-billion-dollar project. So it involves also CO2 transport by ship. 110-kilometer pipeline, and this facility should be able to do 1.5 million tons per annum, so about 50% bigger than the last one. So we're very excited to do the Northern Lights project with our partners. Now, can I move to the next slide, please? And also, where the world is changing is society's demands on companies like Shell in terms of, okay, are you really doing what you're saying? For example, are you able to show us that the CO2 that you're storing, you can do that safely, reliably, that the CO2 stays there? So then you're talking about things like conformance. So can you demonstrate the long-term security of your storage, but also containment. So what happens in the short term? Are we seeing any environmental effects? any early warnings. And the type of risks that we of course have to understand very well is is there anything happening with injectivity, any leakage through faults? What is our well integrity like? Is there any risk of any induced seismicity? And these are all things that society will want to. It's not going to be a trust us, it will be fine. It will be very much a show me world. So the whole area of MMV, so measurement, monitoring, and verification, will be an enormous, interesting field. So, how do you monitor that things are going okay? It's through various means: atmospheric monitoring, marine monitoring, seismicity monitoring, seabed sampling, fiber optics with in wells and with direct acoustic sensing. So, and of course. You need to do this well, but there's also then, of course, becomes an economic challenge, because of course as these facilities get older, we know better on how the storage facilities behave. Can we learn through artificial intelligence or machine learning? Can we maybe more history match the behavior of this, and can we over time do this whole measurement, monitoring, and verification? Can we reduce the spend there by just simply being smarter about the conclusions that we draw? So there's a whole new field coming. Now, moving to the next big thing is hydrogen, and hydrogen we're very excited about, and we've actually one of my previous colleagues in the technology team has just been announced vice president for hydrogen, to look again at the whole opportunity. And the reason why we are so keen on hydrogen, it's clean, it's versatile, and you can use it for anything. You can use it for power, transport, and feedstock for industry. And we started in Shell. We definitely don't get everything right, because we started this in 1993, but we couldn't make it work. We started the business in 1993, and this is where the challenges come for companies, is that you need to have a supply and you need to have a demand. So initially in Germany, we probably overshot in the old days in terms of having 100 filling stations, hydrogen stations in Germany. Well, then you also, of course, need to have sufficient cars that drive it to run around it. Or in a big country like China, we there wanted to set up a hydrogen business, but of course, then you need maybe commitments from car manufacturers. Are they moving towards going for hydrogen fueled cars? So you need to get the supply and the demand right. But yeah, what hydrogen allows you to do is you can integrate it with renewables. You can store it in salt caverns, and I mentioned already, in the near term future, blue hydrogen is probably going to be more likely, but we really want to move to green hydrogen. And then again, similar things, challenges like in CCS come up, like what's the capacity of a salt cavern? What's the injectivity? Again, can we contain it? Hydrogen, doesn't react well with all steel alloys. So, what does that mean for your well construction? And many other things like that. And again, also, this is we've got to work with also the regulators, because hydrogen is something that is unknown to people. You need to there's a lot of education needs to be done, that this can be done really safely, because of course if we can't demonstrate it, we don't get what we call our license to operate, and then and nothing happens. So it's very much not that we should not approach this from a purely a technocrat approach, like we will tell everybody how it works. It needs to be a joint discussion, and clearly hand in hand with regulators. Right, maybe moving to the next slide, also again about hydrogen. So tremendous opportunities there. We are again building very large electrolyzers in Germany. We see opportunities for marine fuel heavy transport to go on hydrogen as well. And maybe in view of time, maybe straight move to the next one, and that shows you a kind of a network, and this is the phenomenal challenge here. So you see how this will need to grow organically to have a full kind of network of hydrogen, even with hydrogen pipelines. This is something that, of course, we're talking to many governments about, governments with. And again, this is a little bit like CCUS. You start with yourself. We have, for example, a very large refinery in Germany, the Rhineland refinery, and there we are also building a huge 10 megawatt electrolyzer. And actually, last few days we've been able to announce one double the size 20 megawatt electrolyzer that we will build in one of the host cities in the 2022 Winter Olympics in China. And again, it's not just us building that electrolyzer, but then also we need to look at, okay, what is the infrastructure around it? How can we create the demand as well? And then, of course, moving then on from, okay, how can we do this on our own sites? We're looking at another electrolyzer near Rotterdam. There's the North H2 project in the north of Holland. These two projects, I should say, we're working towards final investment decisions. So it's ambition for us to move forward with these projects. But you can see, huge, a kind of systemic change coming, where we firmly believe that the subsurface storage of hydrogen is going to have to play a part. Now, moving to the next theme, geothermal. There's many different concepts, of course, around geothermal, starting from more the classic doublet, so a production well, a heat exchanger, and an injection well. The next step in complexity is where you go more closed loop. So it's essentially often with many laterals, and essentially you're moving into a YouTube concept. Now, of course, what that does is, if you can simply use the subsurface as a heat exchanger, and you actually could be independent of the actual geology that you're facing, and that, of course, in turn makes this concept much more applicable in different geographies. Here in Holland, where, as I said, we're a little bit lucky we have got quite suitable geology, but that's not everywhere. So if you can move this around, that would be extremely exciting. So we're also doing trials in that area as well. Then and what I don't think it's been public announced, but it will be that will come in the next few days. But there will be an announcement coming where, again, we are made quite a big cooperation agreement with a metropolitan area somewhere here in Europe that really triggers a lot of geothermal projects. It could be up to 100, but stay tuned for that, because I don't want to preempt the formal announcement that it should be days away. Next would be heat storage. The current energy system in Holland, you could use then the flexibility of having gas supply and underground storage to deal with high winter demand. And finally, let's see, if we go to so on geothermal, just a few more projects to mention. We're actually doing a project with TU Delft. I'm very happy to say, as part of the consortium Geothermy Delft, and will be wells on the actual campus of Delft, together with we're doing that with Hydreco, Geomec, and EBN. Again, a tremendous learning opportunity for us. So given a few more minutes left, and I really want to open it for Q&A. Just a final slide is that the energy transition is all about cooperation. Yeah, this is not about, nobody has got all the answers here. Certainly not Shell on its own. So this is going to be something that is a decade-long process. This is not binary. I'll just switch off oil and gas and go straight into hydrogen. There is a tremendous amount of learning that needs to happen. Unprecedented cooperation really between policymakers, business, consumers, non-governmental organizations. And we need long-term policies, because if we're going to put in 12,000 of these Canadian projects in the ground, we need, as a business, we'll need also stability in policy making. Yeah, that the rules don't change every month, because that makes investment very difficult. And of course, we're very keen to see like things like in Canada, where they have a clear tax for carbon, because you need to create that incentive, because that is how you will attract the capital. And yeah, where do we play? As you've seen, I think one characteristic of projects in the energy transition is in that they're often partnerships, and that's because nobody has the single answer. What we, I think, can bring to this is our experience with very large integrated projects, and of course also our experience with the subsurface. So many IOCs can bring that. That's why Equinor is strong in this. Total is strong. We're all want to leverage that knowledge, and that means that if you are maybe a geologist, or maybe not even at the university, should I study geology? I think there is an additional relevance now of the subsurface, because one characteristic is clear when we look at these integrated projects. The lot has to happen of course at the surface, and a lot about how can I build facilities in the most safe way, in the most economic way, and environmentally effective way. But the big kind of joker in the pack often in all these integrated projects is the subsurface. That is often, if we can get the long-term regulatory framework sorted, the big uncertainty and therefore also the big difference between, is this hydrogen storage project or is this CCS project, will it be an economic success or will we be able to clearly show that we can contain this? Will it be a technical success and environmental success? The big joker in the pack here is, how well do you have control of your subsurface? That's what we've learned in our in our very large oil and gas projects, and this will apply to the energy transition as well. So and I think it's exciting. I think the thinking around needing to make these changes in a way has been, I think, also accelerated by the Corona crisis, because of course that crisis forced us to think, given that oil prices were dropping big time, as a really fundamental kind of shock to the system. And you can then be victim, or you can say, well, we know that we need to literally reshape, but really change ourselves for the future. You might as well just grab that as an opportunity and accelerate your thinking. So when I hopefully, when the public announcements were made on how in detail that all will work in Shell, and that will come early next year, I hope that becomes a little bit clearer. So I think I used up my 30 minutes. Hadi?
Yes, thank you very much, Paul. You are certainly the most on-time speaker we have ever hosted. Precisely 30 minutes. So time management seems to be really nice here. So we have already received plenty questions, and they are all relevant. I would like to just give the floor to Sebastian to categorize and then share the discussion session, and we all look forward to this lively session together. So thanks very much. Sebastian, you're...
Yes, thank you very much, Paul, for this great and inspiring and forward-looking talk. It's not only that you have been the most of the time speaker. I think we've never had that many questions coming in during the talk. And there's
Okay,
one question
that makes me okay. I hope I'll be able to do all of them.
Yeah. I better stop talking past the question on, and I'm going to start with one from Olarinris Sadako that picks up onto something one of our former speakers, Mike Stevenson from BGS, asked. So Olarinris is asking, do you have any plans for implementing similar projects, CCS, hydrogen, etc., where you operate in Africa, for example, in Niger Delta? And previous talks have spoken about energy corridors in Kenya, for example, and east of Africa, especially in Olarinris continues, especially due to the high energy needs in Africa. So what's Shell's?
Well, I can't speak to specific geographies, but it's clear that this is going to, in the next few decades, is going to be exploding in terms of scope. And as I think we will also have to learn on how these projects work. We'll learn a lot from Quest, of course, and we'll learn a lot from Northern Lights. We have got a whole a portfolio of projects that we are looking at, and we're spending also increasing amounts of money to, study their feasibility. But it's clear it's going to be a large, and I think where we would invest in CCUS is often also driven by, well, obviously, the demand, where the demand is for the storage. But also where we have clear alignment with the stakeholders. As we those of us that live in Holland know, we failed to convince the public in a few areas as well. That this was a good thing. There was a project near Rotterdam that we want to do near Barendrecht, which we couldn't convince people that this was actually the people living there. That this was a safe and reliable thing to do. So then you can say, well, what's their problem? No, then that is your reality. That means that you need to think, explain much more what it's all about, and particularly those that have worry about Groningen, the earthquake issue that we have there. That lives in people's minds, and people can be forgiven that they will be not making a distinction between the two, between CH4 production versus CO2 storage. That means by definition we have a communication gap. So that's important, and clearly we need government support, like we've seen in Canada and in Norway, and increasing in many countries in the world. We'll see what comes out of how the EU is doing. Of course, a lot of thinking there as well. But you can already see between the two projects that I've shown that this is evolving very quickly. And it's also true that we really need, by 2030, we really need to see a very different picture in terms of the amounts of CCS projects that are in operation. We need to attract billions and billions of dollars of capital, but we also need to develop some more of the technology on what happen. What is the monitoring that we can do? How can we find the right geologies to store the CO2? Do we understand what happens when the CO2 may react? With minerals in subsurface, so things like reactive transport modeling are important. How could we make sure that we can prove that we don't have, fault planes being affected over time by CO2 and therefore leakage? Because of course that's the worst that can happen. So we're on a big journey here, and it's going to require everybody, not just Shell.
Thank you. I'm going to group three questions. I'm going to bring them up individually so they audience sees them as well. I'm going to group them, and as Yuhang, Dia, and Musa, they all asked about the future training of geoscientists. So how would future geoscience curriculum look like? What is the ideal geoscientist to tackle this challenge? You mentioned the importance of the subsurface. And do we need more geoscience in the future or less geoscience? So grouping those three comments.
Okay, that's a great question, and I must say I've seen that change already. In terms of when I studied in Delft, from in the late 1980s, there was the Faculty of Mining and Petroleum Engineering, and I think TU Delft has taken the opportunity to change it more into a generic name, Earth Sciences, it's called, and that's by no means to that they're ashamed to also be dealing with oil and gas, but it's just more broad. So I think the subsurface. I think it's not going to be less than amount of geoscience that we need. Many CCUS, hydrogen storage, geothermal. How do we deal with containment risk? How can we risk of induced seismicity? How do we pick out the right reservoirs to store the gases in? How do we optimize how we inject, where we inject? Monitoring plans. So that is additional scope, and let's also be clear that the geology that pertains to oil and gas, and we're not ashamed that is going to be part of our business for at least several decades more. It will be more focused, but that will remain a challenge as well. And of course, the easy oil and gas fields have been found. So the very tricky ones, for example, the ones that find themselves offshore in deep water under complex salt structures, which make your seismic go crazy, basically, requires the absolute elite of geologists, mathematicians, artificial intelligence, machine learning. That is going to be part of it as well. But that is on top of a kind of a broadening relevance of geoscience. So that is why we're keen also as Shell to work with many universities, not just Delft, but Cambridge, Imperial, Heriot-Watt, many others all across the world, because we care about that there remains an interest in this, because it will remain relevant, geoscience.
That's really good to hear, and because working at the university, we try to anticipate where the future training needs, the future research needs are, and TU Delft have renamed the departments where we have new courses are coming up left, right, and center. So, and if I can just add, the ideal geoscientist of the future is not only he or she is not just only very credible as with that deep geological understanding, or almost that that affinity, but is also somebody that the way we deliver our work is also going to change. It's going to be much less hierarchical. It's going to be much more natural teams. It will become standard that you will have in your toolkit digital skills or Python, and what I see happening when I joined Shell. It was I joined Shell as a reservoir engineer, so we were the ones that took the geological models and we made the simulation models, and that was almost written on my forehead. That was my identity. That's what I got my pride from. That was the tribe I was part of. We see the same with well engineers. Very strong tribe. All that is going. All that is going to be much more about a geologist of the future will be already also delving into fields like petrophysics or reservoir engineering or geophysics. So it's going to be much broader, and I see more a development of we will need excellent specialists, but rather than we have people maybe more in a niche, you'll see many more people becoming almost call it more almost like a subsurface engineer, that broad, and that will then. And I think that makes it actually, if I had been able to work in that way, that my career would have been even more interesting. I'm not complaining, but it would have been even more interesting. And the successful teams that we see in Shell are the ones that don't think in too deep, functional silos. It's going to be much broader. That's really great to hear. I'm going to switch gears a little bit, and again, there's a group of questions, and I'm going to bring up one and then just add the other questions, and bring up Mark's, because he was a former Shell employee, Mark Bentley, and he was one of our former speakers. He's now at Heriot-Watt University. Hold on, sorry, that's a wrong question for Mark. This was the one I wanted to bring up, and talk about hydrogen. So Mark asked in a similar questions, Bo Wren asked a question around this, Anthony Hallam. for hydrogen, what do you see as the real barriers, or perhaps just the big hurdles to successfully roll out hydrogen across at least Europe?
Yeah, that's a great. It's a great question, and it's really chicken and egg. It's really chicken and egg. So we want to invest, but you got to create the demand first. But I'm actually, even in the last 2 years, it's just change has been massive. You also have in Rotterdam, the Portos project. You got North H2. It's almost like there's such a pull now from governments, even Shell, we wouldn't even get away without seeing that in our business plans much more, because we have a board, and the board also listens to what society expects. So it's really important that we do the groundwork, so that we get the stakeholders in line, get the right technology out there. But I see tremendous pull. I see, the European Union probably taking a front role in terms of also, subsidizing or helping people to start this up. But it's to create the market. That is a big thing. And I think in Europe, that's probably one of the areas where we'll be probably be worldwide one of the front runners. So it is about and it's because hydrogen is so versatile. I think it needs a lot of explaining. It needs a lot of celebration of early achievements. These big electrolyzers. These are big projects, but publicize very clearly breakthroughs on hydrogen for heavy trucks. For marine applications. I don't see any shortage of pull right now. I see that we all need to really invest heavily in getting our act together, because it has to work economically as well. This is not going to happen overnight, but I see a night and day change in even the last 2 years. So I'm actually almost feel in a rush that let's get our act together, because the pool is so enormous.
Thank you. So Zaid Janga asked a question, just to follow up on your last answer. Maybe it's an optimistic question, but off topic, but how long do you foresee until hydrogen, other clean energy sources overtake oil and gas as the premier energy option? So if you take your crystal ball, when is this going to happen? In the near future, or are we still a long way away?
Yeah, it depends how you define the near future, of course. But Zaid, it's a great question. So one thing that we are clear, what we're getting pretty convinced, is that the peak of oil production may well be behind us. So that means oil companies used to fall over each other to show the biggest volume of production, and that is you've seen also maybe announcements from BP that they expect their production to go down by I don't know, 10, 20, 30%, or but significantly. So when will it be the premier? I think if you saw the plots on the whole infrastructure that needs to be there on hydrogen pipelines, I think it will be sometime before it becomes the premier energy source. I do see, and I don't have the scenarios with me, but maybe that we can make available on this is to we've got these scenarios that we use in Shell. We publicize them as well. They're not predictions, but they are scenarios, and there you can see how we see the energy mix evolve, including hydrogen, including nuclear, coal, everything. And of course, the answer to your question is also different by geography as well. This will happen. The trend is going to be unmistakable, but we'll all be going from different starting points and at different speeds. But I think so that maybe is something we can make available, these scenarios. And then of course what we can't control is also how the world as a whole will evolve. Will it evolve more in a in a spirit of more, jointly as a planet, we're going to cooperate and deal with this challenge, or are we going to be a little bit more, looking at our own little insular interest, because that depends also the speed with which we're going.
Fantastic, thank you. So I'm just looking at other questions. I'm going to group them. The one question is really better than the other, and I need to apologize if I can't bring up any all the individual questions. I'm trying my best to group them and to touch upon the themes that are getting asked. So you talked about the economics, and there's a number of questions of economics. I'm going to bring in two particular questions here. The first one is from Wilhelmine. Would Shell remain interested in CCS and hydrogen, even if these may not yet be fully financially competent at this moment? If so, why?
Well, we would be lying if we would say today we've got all the answers how to make a viable business out of CCUS and hydrogen. And this is where you see maybe the reason why it's not a binary thing. We are committed that we're going to be successful here with others, in cooperation. So this is where the benefit is, where you have the benefit of being a fairly chunky company with a big cash flow, is that you can afford now to invest and to learn, and we can afford to learn about businesses that are not from day one profitable. I mentioned that we started our first hydrogen business in 1993. Well, we got that a little bit too early, but that is why you need an underlying business of oil and gas. We need to stay good at that, and that helps to literally almost fuel the study time and the early investment. And not everything will be profitable. Without a cooperation of Norway and Canada, these CCS projects would also not happen. And one thing that we've been arguing for as Shell is and we have that in Canada, CO2 needs to have a price, or a tax, if you will. A certain amount of dollars per ton that you emit will cost you. That's how you then create an economic incentive to not emit them or to store them. And that is what drives, in the end, also behaviors. That is something, of course, we need governments for. But we don't, clearly, we are a company. We've got shareholders. We need to, people want a dividend. So yes, you need to find a line to that profitability. But without companies seeing the line to that profitability, you're not going to get the capital either. So it has to work simply. Governments can't make these projects happen by themselves by magic. So there needs to be an economic reality, and we're convinced that economic reality will be there because the urgency is there. We're all of us on this same planet. But does it have to be profitable every project right now that we start profitable from day one? No, but that's the benefit of being a larger company with a longer view.
Thank you. I'm going to continue with two questions around economics. So Mosen asks, you mentioned CO2, so from a business standpoint, what's the prospect of Shell for utilization of captured CO2 in EOR projects, conversion to chemicals and biomass? Is that something that could help to make the economics work out better?
Yeah, that is an interesting topic. The CO2 EOR. We do, you may know, we do quite a lot in EOR in places, enhanced oil recovery. For those that are not familiar, in places like Oman, and we're involved in Kuwait. Particularly those areas where you have large in-place volumes, where even 0.1% improvement of your recovery factor would mean a lot of oil. And can you combine that with CO2? That's an area that we are indeed studying. That will be part of the palette of options. We have quite a in-depth knowledge of that. We have a lot of expertise in this area. So this definitely will be one of these things where we need to play to see where this is possible, where we can combine enhanced oil recovery with storing the CO2. And of course, you can argue what normal water flood projects, if you do those well, and for example, through the use of polymers, you switch off, otherwise water producing zones. In the end, of course, a water flood project is de facto a big washing machine where you're circulating water all the time, and that triggers a lot of energy. So with polymers, if you can increase the efficiency of your water flood, and therefore be less of a washing machine, that in itself also has, of course, an environmental footprint improvement. So that is definitely something that we that is in our repertoire, so to say. Yes.
Thanks. Staying on the topic of economics, and Charles Boyce has asked a number of questions, and sorry, Charles, I think some Paul has already answered, but I'm picking this one because I find it very interesting, and I think it's not just with respect to Shell, but you mentioned investment in the energy transition, but at the same time, reserve life for Shell has dropped over the last 8 years, wanting investment in exploration. How can you do this simultaneously and make the investment into new energy sources, and also keeping the core business, which is paying the bills at the end of the day, running?
Yep. No, that's a great question, Charles. So you've seen public announcements in terms of our capital, because we need to tighten our belt. So we're spending less capital, particularly in the upstream. What we're doing is trying to spend it in fewer individual places, and places where we're very familiar. So we're going to have a very focused portfolio, and so overall that spend will go down, and that should make space for more energy transition related investments. And let's also not forget, I talked about trends. This is not binary, because at the same time, we have a very big footprint in deep water, and we've also announced that we're actually still going to do exploration, and actually we just announced a new venture. So that is an area where we will stay, because we've got quite a lot of knowledge around it. Offshore Mexico is an important area as well, but it's going to be more focused. And again, also that was announced, there will be 8 or 9 areas that will focus on worldwide. And if you pinpoint your investment, and you're less worried than before about your production level, and less worried about your reserves life, because if your reserves life is low, then of course at some point you will go down. If you're less worried about volume and you focus on value, then that will free up that capital.
Thank you. So I do understand, Paul, you have to leave very sharply, so I'm going to pass a very quick question.
I can be a few minutes late, because I don't want to cut it off too short, too quickly.
Well, I think we could be hours late here. The questions still keep coming in, but I thought this is a really interesting question, again, where we're heading in terms of technology. So Ben asked, does Shell plan to develop new tech in-house, or is it about acquiring startups? You mentioned Equinor, for example, not Equinor, Ever, the new breakthrough technology in geothermal energy, or is it more collaborative with Equinor, Total, and we're using new tech as a competitive advantage? So how do you actually develop the technology? Collaboration, in-house, buying up startups? Yeah,
great question, Ben. It's actually all of the above. So we are clear that in the energy transition, it's going to take cooperation. There will be, for example, you could do a project with another IOC like Equinor or BP or Chevron, and they might have niche skills in another part of the chain. As I said, we've got quite a large R&D setup that we're very proud of, and we'll focus that also going forward. You'll see much more R&D activity in energy transition. And you mentioned startups as well. We have got several technology ventures, I call it, we've got a whole part of Shell that specifically focuses on where are the great startups that we can cooperate with, because for sure we will not be the only ones with the bright ideas. And if you want to accelerate something, and I hope I made clear that, you know, really the challenge is on, we need to now get after this. If we're all going to sit in our own little office and think we can have the answer, that's not going to work. So in that sense, also cooperation is the name of the game, and you maybe can call it whatever, you know, like a global natural team where you need your own skills that we're proud of and that we will use to bring something extra, but just cooperation with others. That's going to get to success.
Thank you much. Thank you, Paul. So I'm going to hand over to Hadi for some final comments. Thank you to the answer for to the audience for all the fantastic questions. Apologies, I couldn't pass on every question to Paul. We would be sitting here for at least another hour. So thank you, Paul. Thank you, audience. Over to you again, Hadi.
Yeah, thank you very much. It's also the record of these questions are also will be there in the channel as well. A very, very pleasant discussion moment. I would like to take the chance to announce our next speaker is going to be Professor Kamal Singh from Heriot-Watt University, so not so far from Sebastian. And Kamal will speak about imaging porous materials across scales. So until next time, the same time, hour, Thursday, 4 p.m. Central European, 3 British time, 7 a.m. California. Stay well, happy, healthy, and tuned, and we all see you next week. Thank you very much, Paul. It was a great event today.
Thanks for having me. Thank you.